Ever looked up at the night sky and just thought, wow, how do we get stuff up there?
It's amazing, isn't it?
Yeah, it's mind-boggling. And that's what we're going to dive into today, the science behind spacecraft engineering.
Yeah, we've got a ton of material to go through.
Blueprints, mission reports, all that stuff.
The whole shebang.
We really want to understand what goes into designing, building, and operating these incredible machines.
And maybe uncover some surprising facts along the way, right?
Absolutely. So buckle up, everyone. Get ready for a journey beyond Earth's atmosphere.
Yeah, when you start to look into it, it's incredible how much ingenuity goes into every single component.
Right. So let's start with the basics. When you're building a spacecraft, does it all begin with some kind of universal blueprint?
Well, it's fascinating because there's no one-size-fits-all approach, you know?
Okay, so it's not like just pulling a plan off the shelf.
No, definitely not. Building a satellite to orbit Earth is completely different from landing a rover on Mars or sending a probe to, the outer solar system.
Right. Each mission has its own goals and its own challenges.
Exactly. And those challenges directly influence the design of the spacecraft.
So purpose-built for sure, but where do you even begin?
Is there a common starting point, you mean?
Yeah, like is there a foundation to these machines?
You could say that every spacecraft needs a strong framework called the bus.
The bus. What is that?
It's essentially the backbone of the spacecraft, the skeleton that holds everything together.
Okay, so all the essential components like the propulsion system, power source communications, and scientific instrument.
Everything. Yeah, it all gets housed within the bus.
So it's like the load-bearing structure.
Yeah.
Got it. But what's it made of? It's got to be both lightweight and strong enough to survive launch in space, right?
Absolutely. We're talking about using advanced materials here,
Yeah.
things like titanium alloys for their strength-to-weight ratio.
Right, titanium, very strong, but also lightweight.
And then you've got carbon composites known for their stiffness and resistance to extreme temperatures.
So the bus is built to withstand all those intense vibrations during launch.
Yeah, and then the massive temperature swings in space.
I bet that's a wild ride, hot and cold.
It really is. And on top of that, you've got the constant bombardment of micrometeoroids.
Micrometeoroids. Now those sound terrifying.
Yeah, imagine tiny high-velocity projectiles just zipping around in space.
Even a small piece of debris could do some serious damage, I'd imagine.
Oh, absolutely. Even a speck of dust can cause significant damage at those speeds.
So how do you protect against that?
That's where the multi-layered shielding comes in.
So layers of protection.
Exactly. The outermost layer acts as a sacrificial barrier, basically. It breaks apart upon impact to protect the vital components underneath.
Wow, so it's like a built-in bulletproof vest for the spacecraft.
Kind of, yeah.
Yeah.
And it's essential for ensuring the mission's success.
Okay, so we've got our super strong framework protected from tiny space bullets.
What's next?
Well, we got to get this thing moving, right? Most people picture those huge rockets blasting off. What's the science behind that?
Oh, yes. The iconic fiery blast-off. That's the power of chemical rockets.
And they've been the workhorse for a long time, right?
They really have. They're powerful, reliable, and they've gotten us pretty far.
But are they the only option for getting to space?
Well, for longer missions, especially those heading deeper into space, there's another contender, ion thrusters.
Ion thrusters. Okay, now you've got my attention.
Yeah.
How are those different?
Well, imagine this. Instead of a fiery explosion, you have this gentle, almost invisible thrust.
Invisible thrust.
Yeah, ion thrusters use electric fields to accelerate charged particles, which are called ions.
Interesting. So instead of burning fuel, they're using electricity.
Exactly. And this creates a very efficient and continuous form of propulsion.
I see. So they might not have that raw power of a chemical rocket for launch, but they're better for the long haul.
You got it. It's kind of like a marathon versus a sprint.
I like that analogy.
Yeah.
So where does each type of propulsion excel?
Well, chemical rockets are great for that initial burst you need to overcome Earth's gravity.
Right, that powerful push off the launch pad.
But once you're in space, ion thrusters can gradually accelerate the spacecraft to incredible speeds over a long period.
So for missions to the outer planets or beyond, you probably want to use ion thrusters.
Absolutely. A great example is NASA's Dawn mission. They used ion propulsion to travel to and orbit the asteroid Vesta and the Dwarf Planet series.
Wow, so it's kind of like having different engines for different phases of a journey.
Precisely. Each type of propulsion system has its own strengths and weaknesses.
This is fascinating. Okay, so we've got our structure, we've got our propulsion.
What's next?
How about power? How do you power something that's millions of miles away from a power outlet?
Now, that's a question that has driven a lot of innovation over the years.
It's not like you can just plug it into a space station, right?
Not quite. And just like propulsion, the answer depends on the mission.
Okay. So different missions, different power sources.
Exactly. For spacecraft that are relatively close to the sun, like those orbiting Earth or exploring the inner solar system, we can use solar arrays.
Those are the big wing-like panels you see on satellites, right?
Yep, those are them. They're
Okay.
basically giant solar panels that convert sunlight into electricity.
So a pretty reliable power source as long as you're close enough to the sun.
Precisely. But what happens when you venture further out where sunlight is weaker?
Good question. What do you do then?
For those deep space missions, we turn to something called radioisotope thermoelectric generators, or RTGs for short.
RTGs.
Yeah.
That sounds like something straight out of a sci-fi movie.
They kind of are, in a way. They harness the heat generated from the natural radioactive decay of plutonium.
Wow, so they're using radioactive decay to generate electricity.
Exactly. It's a really ingenious way to provide a reliable power source, even in the cold and darkness of deep space.
Yeah, they've powered some of our most far-reaching missions, right?
Absolutely. Like the Voyager probes, which are still sending back data from the edges of interstellar space.
Decades after they were launched. That's incredible. Okay, so we've got power figured out.
What else is on your mind?
Well, space is a pretty harsh environment, right?
You could say that.
I mean, it's not just cold and dark. There's also radiation and extreme temperatures.
Mm-hmm.
How do you protect the spacecraft and all those delicate instruments from that?
It's definitely one of the biggest challenges in spacecraft design.
It's going to be tough to build something that can withstand all that.
It is, but engineers have come up with some pretty clever solutions over the years.
Okay, so let's break it down. How do you handle those extreme temperature swings, for instance?
Well, first you have to remember that spacecraft can go from the blistering heat of direct sunlight to the frigid cold of shadow incredibly quickly.
Wow, that must put a lot of stress on the materials.
It does. So to manage that, they use a variety of techniques.
Like what?
Well, one is multi-layer insulation, which is kind of like a high-tech space blanket.
To help regulate the internal temperature.
Exactly. And then they also use reflective coatings to deflect sunlight and prevent overheating.
Smart. And what about getting rid of excess heat?
For that, they use specialized radiators to dissipate heat into space.
So it's like giving the spacecraft a built-in climate control system.
In a way, yes. It's all about maintaining a stable internal temperature, no matter what's happening outside.
That's impressive. What about protection from radiation?
Radiation shielding is crucial, especially for sensitive electronics and, of course, for human missions.
Right, you don't want to fry your circuits or endanger the crew.
Exactly. So they often house the electronics in protective casings made of radiation-resistant materials.
And for human missions, you need even more shielding.
Absolutely. The crew quarters need to be heavily shielded to protect the astronauts from the harmful effects of radiation.
Must be a tough balancing act, though, right?
What do you mean?
Well, adding more shielding adds more weight, which makes it harder to launch and maneuver the spacecraft.
That's true. It's always a trade-off between providing adequate protection and keeping the weight manageable.
It sounds like protecting a spacecraft from the extremes of space is almost as challenging as getting it there in the first place.
It's a constant challenge for sure, but that's what makes spacecraft engineering so fascinating. It pushes us to develop new technologies and materials and to find creative solutions to overcome these obstacles.
It's really incredible when you think about it. Building a machine that can not only survive, but thrive in such a hostile environment.
It's a testament to human ingenuity and our determination to explore the universe.
It really is. Okay, so we've covered the structure, propulsion power, and protection from the harshness of space.
What's next?
But how do we stay in touch? How do we send commands and get data back from these spacecraft when they are millions, even billions of miles away?
Communication. That's another crucial aspect of space exploration.
It's not like we can just pick up a space phone and call them, right?
Haha, no, not quite. It's a bit more complicated than that.
I bet. So how does it work?
Well, spacecraft are equipped with high-gain antennas that can send and receive signals across vast distances.
Okay, so those antennas are like their lifeline to Earth.
Exactly, but the signals themselves are incredibly faint by the time they reach us.
So how do we pick them up?
That's where NASA's Deep Space Network, or DSN, comes in.
Ah, the DSN. I've heard of that. Those are those giant satellite dishes, right?
You got it. They're strategically placed all over the world.
Why all over the world?
Well, it ensures that no matter where a spacecraft is in its journey around the sun, at least one antenna can maintain contact.
So it's like having a giant ear constantly listening for those faint whispers from across the solar system.
That's a great way to put it. And these antennas are incredibly sensitive. They can pick up signals from billions of miles away.
Wow, that's mind-boggling. Even from spacecraft that have left our solar system.
Exactly. Even from interstellar space. It's amazing what we can achieve with technology.
It really is.
Yeah.
Okay, so we can communicate with our spacecraft, but how do they actually find their way across the vastness of space? Are there like cosmic GPS satellites out there?
Not exactly GPS as we know it, but they do have incredibly precise navigation systems.
So what do they use?
They rely on a combination of onboard sensors, gyroscopes, and something called star trackers.
Star trackers.
Okay.
That sounds pretty cool. What are those?
They're basically specialized cameras that can recognize the patterns of known stars.
And they use that information to navigate.
Precisely. They compare those step patterns to onboard star catalogs, and using some incredibly complex algorithms, they can determine the spacecraft's orientation with extreme accuracy.
So they're basically using the stars as their guideposts. It's like having a celestial map built right into the spacecraft.
Exactly. And this is crucial for keeping the spacecraft on course, pointing its instruments in the right direction, and ensuring that it reaches its destination.
That's brilliant. And I imagine this becomes even more critical for missions where real-time communication with Earth isn't possible, right?
You're absolutely right. As we venture further out, communication delays become a major factor.
Right. So you can't just joystick a spacecraft around when it's billions of miles away.
Exactly. Imagine sending a command to a Mars rover and having to wait minutes or even hours for a response.
That would make things pretty difficult, I
It
imagine.
would. So that's where autonomous systems come into play.
Autonomy. So we're talking about spacecraft that can think for themselves.
Well, in a sense, yes. We're not talking about sentient robots or anything like that.
Okay, good. Because that would be a little scary.
Yeah. But we are talking about spacecraft that are equipped with increasingly sophisticated AI.
AI. So artificial intelligence in space.
Precisely. This allows them to make certain decisions, adjust their course, and even conduct scientific observations without constant human intervention.
So they can adapt to unexpected situations and carry out their mission even when they're out of touch with Earth.
Exactly. And as AI technology continues to advance, we'll see even more autonomous spacecraft in the future.
That's pretty mind-blowing. It really does feel like we're on the cusp of a whole new era of space exploration.
It's an exciting time to be involved in this field, that's for sure.
It really is.
Yeah.
So we've talked about the basic building blocks of a spacecraft.
The bus propulsion, power communication, and
Yeah.
navigation.
We've also touched on the challenges of protecting these delicate machines from the harshness of space.
From extreme temperatures to radiation to micrometeoroids.
But with all this talk about robots and AI, it's easy to forget that ultimately it's humans who are behind all of this.
That's true. And when it comes to sending humans into space, the challenges are even greater.
I can imagine,
Yeah.
right? Because now you're not just building a machine, but a habitat where people can live and work safely and hopefully comfortably.
Exactly. And that brings a whole new set of considerations into play.
So what are some of the unique challenges of designing a spacecraft for human spaceflight?
Well, for starters, you need to create a fully self-sufficient life support system.
Okay, so what does that entail?
Think about it. You need breathable, air-clean water food and a way to manage waste.
And all of that within a sealed environment, millions of miles from Earth.
It's essentially like designing a miniature Earth capable of sustaining human life indefinitely.
That's a tall order.
It is. And then there's the issue of radiation, which is a much greater concern for humans than for robots.
Right. We talked about radiation shielding earlier, but for crewed missions, it's even more critical.
Absolutely. You need much more robust shielding to protect the crew's health, especially on longer duration missions.
And I'm guessing that adds a lot of weight.
It does. And weight is always a factor when designing a spacecraft.
So it's a constant balancing act between safety and the practical realities of launching and maneuvering such a heavy vehicle.
Exactly. It's a complex engineering challenge, but one that we're constantly striving to overcome.
Because ultimately the goal is to make space travel as safe and sustainable for humans as possible.
Precisely. And to expand our presence in the cosmos.
It's incredible to think about all the factors that go into designing a spacecraft for human spaceflight.
Yeah.
It's not just engineering and physics, but also biology, psychology, even interior design.
It's a truly multidisciplinary endeavor. It requires expertise from a wide range of fields.
And that's what makes it so fascinating. It's a testament to human ingenuity and our relentless drive to push the boundaries of exploration.
I couldn't agree more. It's an incredible privilege to be a part of this journey.
It really is. Okay, so we've covered a lot of ground today, from the basic components of a spacecraft to the unique challenges of human spaceflight.
And we've only just scratched the surface.
There's so much more to explore. But before we dive into the more advanced concepts, I want to take a step back for a moment.
Okay, this sounds good.
We've been talking a lot about the technical details, but what's the ultimate purpose of all this effort? Where are we ultimately trying to go with space exploration?
That's a great question, and it's one that has captivated philosophers and scientists for centuries.
Because it's about more than just building machines, right?
Exactly. It's about understanding our place in the universe, about pushing the boundaries of human knowledge and capability.
It's about that age-old desire to explore the unknown to see what's out there.
Precisely. And space, with its vastness and mystery, represents the ultimate frontier.
It's a challenge and an inspiration and a source of endless wonder.
Exactly.
Yeah.
And each mission we send out, each spacecraft we design and build represents another step further into that unknown.
So it's not just about reaching a specific destination. It's about the journey itself, about constantly pushing the limits of what we know and where we've been.
I love that way of putting it. It's about expanding our horizons and discovering new worlds, new possibilities.
And who knows what incredible discoveries await us out there.
New life forms, new planets, new mysteries to unravel.
The possibilities are truly endless. It's incredibly exciting.
It really is. And I think it's important to remember that the true value of space exploration lies not just in the answers we find, but in the questions we ask along the way.
I agree. It's about the spirit of inquiry, the thirst for knowledge, and the courage to venture into the unknown.
And that spirit is embodied in every spacecraft we send into the cosmos.
Each one is a testament to human ingenuity, a symbol of our relentless pursuit of understanding, and a beacon of hope for the future of our species.
Beautifully said. And that spirit of exploration, it's what drives us to keep innovating, to keep pushing the boundaries of what's possible in space.
Yeah, and speaking of innovation, what about the spacecraft themselves? Are there any radical new designs or technologies on the horizon?
Oh, absolutely. There are some really exciting advancements in the works, things that could completely reshape the future of space exploration.
Like what? Give us a glimpse into the future.
Well, one area that has the potential to be truly transformative is advanced propulsion systems.
Okay, so beyond chemical rockets and ion thrusters.
Exactly. We've talked about those, but there are other concepts being explored that could revolutionize how we travel through space.
Okay, I'm all ears. Tell me more.
Well, one idea that has captured the imagination of scientists and engineers is nuclear fusion propulsion.
Nuclear fusion propulsion.
Hmm.
Wow, that sounds pretty ambitious.
It is. It's basically harnessing the power of the same process that fuels the stars to propel a spacecraft.
So we're talking about harnessing the power of the sun.
Essentially, yes. And if we can crack this technology, it would open up incredible possibilities.
Like what kind of possibility?
Well, for starters, it could enable interstellar travel,
Interstellar travel, meaning?
meaning we could travel to other star
Yeah,
systems, to destinations far beyond our own solar system.
Wow, that's mind-blowing. That's something I never thought I'd see in my lifetime.
It's definitely a long-term goal, but it's one that's within the realm of possibility with technologies like nuclear fusion propulsion.
So interstellar travel is on the table.
hmm
What else is out there? What other futuristic propulsion systems are being explored?
Another intriguing concept is the solar sail.
I've heard of those. They sound almost poetic, like a ship sailing on the cosmic winds.
Exactly. It's a very elegant concept. It utilizes large, highly reflective sails that capture the momentum of photons from the sun.
So instead of carrying fuel, you're using the inexhaustible energy of sunlight.
Precisely. It's a very low thrust but continuous form of acceleration, making it ideal for long-duration missions.
Okay, that makes sense. But I imagine you'd need a pretty big sail to generate any meaningful thrust.
You're not wrong. We're talking about sails that could span kilometers in diameter.
Wow, that's massive.
It is, but the beauty of solar sails is that they require no propellant.
So no need to lug around heavy fuel tanks.
Exactly. This makes them very attractive for deep space missions where every gram of weight counts.
Fascinating. So we've got nuclear fusion propulsion and solar sails. These sound like technologies straight out of science fiction.
Well, what's considered science fiction today often becomes science fact tomorrow.
That's true.
Hmm.
So what about those futuristic spacecraft designs we see in movies?
Mhm.
Are any of those concepts actually being explored seriously?
Some of them are more grounded in reality than you might think. For example, there's a lot of research going into rotating habitats that could simulate gravity.
Like a giant spinning wheel in space? Yeah, I've seen that in a movie somewhere.
Exactly, like in 2001, A Space Odyssey, that classic spinning space station.
Right, so the idea is to use centrifugal force to create artificial gravity.
Precisely. And this would be a game changer for long-duration missions.
I think.
Because prolonged exposure to weightlessness can have negative effects on the human body.
Right, like muscle atrophy and bone density loss.
Exactly. So having artificial gravity would help to mitigate those risks and make space travel much more sustainable for humans.
Okay, that makes sense. So artificial gravity is definitely something scientists are looking into. What other science fiction-y ideas are being explored?
Another one that's gaining traction is space-based manufacturing.
Space-based manufacturing, as in setting up factories in space.
Exactly. We've talked about 3D printing in space, but imagine taking that a step further and establishing large-scale manufacturing facilities in orbit.
Wow, that's a pretty bold idea. Why do that?
Well, for one, you could take advantage of the unique conditions of space, such as microgravity and vacuum.
Okay, and how would that be beneficial?
It would allow us to create materials and products that are simply impossible to manufacture on Earth.
Really? Give me an example.
Well, certain alloys, for instance, can be made much purer and with more desirable properties in microgravity.
So we could potentially manufacture things in space that would have applications here on Earth.
Absolutely. It could revolutionize fields like medicine materials, science, and electronics.
That's pretty mind-blowing.
Yeah.
It sounds like the future of space exploration is going to be just as much about what we do in space as it is about where we go.
I completely agree. And as we continue to push the boundaries of what's possible, who knows what incredible discoveries and innovations await us?
It's an incredibly exciting time to be following the evolution of space exploration, that's for sure.
Yeah.
It really is exciting. Going through all this, it really strikes me that building a spacecraft is like this incredible blend of disciplines, pushing the limits of engineering, physics, material science. It's amazing.
It's a true testament to human ingenuity, right?
Yeah, absolutely. And the thing is, it feels like this journey of innovation is far from over.
Oh, definitely. We're constantly discovering new ways to make spacecraft even better. Stronger, lighter, more efficient, more intelligent, you name it.
So what's next? What are some of the breakthroughs on the horizon that you're most excited about?
Well, in terms of things that could reshape the entire landscape of space exploration, I think advanced propulsion systems have the biggest potential.
Okay, we touched on this earlier with nuclear fusion propulsion and solar sails, but is there anything else brewing?
Well, those are definitely two of the most promising concepts, but there are other ideas out there that are being explored.
I'm all ears. What else is out there that could revolutionize space travel?
One area that's particularly interesting is antimatter propulsion.
Antimatter. Now that sounds like something straight out of Star Trek.
It does, doesn't it? But the science behind it is actually quite sound.
Okay, so how does it work?
Well, in simple terms, when matter and antimatter collide, they annihilate each other, releasing an enormous amount of energy.
And we could use that energy to propel a spacecraft.
Exactly. In theory, a small amount of antimatter could produce a tremendous amount of thrust.
Okay, but isn't antimatter incredibly rare and difficult to produce?
That's true. It's one of the biggest challenges facing antimatter propulsion, and it's also incredibly expensive to produce.
So it's not exactly a technology we'll be seeing anytime soon.
Probably not in the near future, but it's definitely an area worth exploring further.
Because the potential payoff is huge, right? If we could figure out how to harness antimatter for propulsion, it would open up a whole new realm of possibilities for space travel.
Absolutely. We're talking about potentially reaching speeds that are a significant fraction of the speed of light.
Wow, that's mind-boggling. So interstellar travel wouldn't just be possible, it'd be much faster.
Exactly. We could potentially reach other star systems in a matter of years or even decades.
That's incredible.
Hmm.
Okay, so antimatter propulsion is a long-term goal, but one with incredible potential. What about some of the other futuristic technologies we see in science fiction? Are any of those becoming more realistic?
Well, one that comes to mind is artificial gravity.
Yes, like that spinning space station in 2001, a space odyssey.
Exactly. That's one way to create artificial gravity using centrifugal force.
And why is artificial gravity so important for space travel?
Well, as we've discussed, prolonged exposure to microgravity can have some pretty detrimental effects on the human body.
Right, muscle atrophy, bone density loss, things like that.
Exactly. So having artificial gravity would be a game changer for long-duration missions. It would allow astronauts to stay healthier and stronger for extended periods in space.
It would make space travel much more sustainable for humans in the long run.
Precisely. And it would open up the possibility of even more ambitious missions, like sending humans to Mars or beyond.
I see. So artificial gravity is definitely a technology worth pursuing.
Absolutely. And there are actually a number of different concepts being explored for how to create it.
Like what?
Well, one idea is to use rotating habitats, as we've discussed.
Yeah.
But there are also concepts involving magnetic fields or even manipulating space-time itself.
Wow, those sound pretty far out.
They do, but that's the beauty of space exploration. We're constantly pushing the boundaries of what's possible.
It's a never-ending quest for knowledge and innovation.
Exactly. And that brings us to another futuristic concept that's becoming more and more realistic: space-based manufacturing.
We touched on this earlier, but remind me again, what are the advantages of manufacturing things in space?
Well, for one thing, you can take advantage of the unique conditions of space, like microgravity and vacuum.
And how would that be beneficial?
Well, in microgravity, you can create materials with properties that are simply impossible to achieve on Earth.
Really? Give me an example.
Well, certain alloys, for instance, can be made much purer and with more desirable properties in microgravity.
So we could manufacture things in space that would have applications here on Earth.
Precisely. It could revolutionize industries like medicine, materials, science, and electronics.
That's pretty mind-boggling. So instead of just building things for space, we could be building things in space that would benefit life on Earth.
Exactly. It's a whole new frontier for manufacturing, and one with incredible potential.
It sounds like the future of space exploration is going to be just as much about what we do in space as it is about where we go.
I completely agree.
Yeah.
And as we continue to develop new technologies and push the boundaries of what's possible, who knows what incredible discoveries and innovations await us.
It's an incredibly exciting time to be following the evolution of space exploration, that's for sure.
It really is.
Well, we've covered a lot of ground today, from the fundamental principles of spacecraft engineering to the mind-blowing possibilities of interstellar travel, space-based manufacturing, and artificial gravity.
It's been a fantastic journey through the world of spacecraft.
And I think anyone listening to this is going to look up at the night sky with a whole new appreciation for the marvels of human ingenuity that are up there exploring the cosmos on our behalf.
I certainly hope so. And maybe it will even inspire some future engineers, scientists, or astronauts to contribute to this incredible field.
It's a field that's full of possibilities and challenges, and it's one that's constantly evolving.
That's what makes it so exciting.
It really does. So as we wrap up this deep dive into the world of spacecraft engineering, what's one key takeaway you would leave our listeners with?
That's a great question. I think I would say the spirit of exploration is alive and well, and it's driving incredible innovation across a wide range of fields. What we're learning today about building machines for space has the potential to not only unlock the secrets of the universe, but also to improve life here on Earth.
That's a wonderful thought to end on. So the next time you look up at the night sky, remember the incredible human ingenuity that made space exploration possible. And maybe, just maybe, you'll be inspired to reach for the stars yourself.
Keep looking up and keep exploring.